Okay, so I begin with what was already mentioned in the introduction, and this is the kind of problem we are facing, that we need to be able to tell the local terrestrial story in a global way. And when I say terrestrial, it's a reference to Bruno Latour, a term that he used in Down to Earth, a book from 2018. Basically, it's talking about the local space, but not in a kind of nationalist way, but more like uh, connected to the Earth, a terrestrial story. And when I say our diminishing material horizons are interconnected, basically, I mean that, one decision in one local place, because everything is now so globalized, can really affect the soil of a very distant place. And, so many decisions are being committed virtually and abstractly, and, and also one effect here of the environment goes to the other. So we have to find a way to connect all these local spaces if you want to tackle like this climate crisis. And we are now adding to this corona crisis, which makes us lose our capacity to be co-located, meaning like we can't, really now share the local space. And then even without corona, there's just so much information that we need to gather from different local spaces around the Earth. We can't be everywhere, and we can't share all this information. We need technology for that. So I'm having three suggestions on what we can do, and they're all kind of interconnected. So one thing I'm suggesting is that we need to expand narratives to the non-human. So storytelling and narrative inquiries need to start accounting to agential realism. You may know this as a new materialism, but basically the idea that the non-human has the agency, is reacting to human and other, and participates in this system of narratives. So, and I'm referencing here one article by Rosiek and Snyder. They are talking about this narrative inquiry and new materialism. But basically, if we want to start tackling the environment that we live in the narratives that we tell, we have to start considering this reactive role of matter in narratives, not just tell the human kind of perspective, but also tell the matter perspective. And then my second suggestion is that we need to start moving from reporting to teleporting. And what I mean by that is with not just having a human look at their reality and then try to tell the story and represent it in some way, but we need to find a way to actually bring the remote reality from the distance place that we are reporting to and into the viewer, the user, the consumer. So I call this teleporting. We can somehow, with technology, for example, use all kinds of sensing technologies. We can carry material properties from one place to another. And of course, it's all reduced and represented by the sensors themselves, by the technology. But this is still one step further than just accounting for the events. We actually now bring the material with us. And then my third suggestion would be about situated technological mediation. That means, so now how the way we consume information, as you all know, we are absorbed into screens, and everything is usually flat. And even when there's this shift to virtual reality, it makes things worse, because we are reinforcing this mind-body split. That's I write here, humanity has worked so hard to erase, and reference one article by Penny who describes this well. But the idea is that all these technologies kind of makes us lost in abstract representations, and it makes it so easy to neglect the ground that we stand on when we are absorbed in the flat virtual medium. So how can we make technology more situated and grounded when we are consuming this information? How can we make this medium more to this earth? That's another question I want to try to tackle. And I will be doing this using some case studies of things I have been working with. So first thing I want to talk about is LiDAR. LiDAR is a laser scanning technology that you can nowadays use to scan material from above, or not from above, but you can do it from an airplane, you can even do it from a satellite, and you can gather information about the material of the environment, the 3D information in a massive scale. So you can just, like in this example, we are showing this is a forest that was affected by fire. I think this is in California, and you can see there's like a centimeter resolution of the material, and this was all gathered by an airplane. And when you are doing post-processing on this, you can find really rich information about the environment. I will specify some of that. I want to show you one demo. So one thing about this LiDAR is that these data sets that are being scanned, they are now being increasingly available to the public from many places. I want to look at this. Are you, by the way, still seeing, are you seeing now this list?
Yes.
Okay. This is the USGS, the United States Geological Survey Institute. There is a huge list here of data. By the way, Finland's data is also public. But for example, if I search here about the wildfires in California, a scan that was done in 2018, and we are talking about a data set of almost 5 billion points gathered. And just quick example of how this is viewed. This is a cesium ion platform. It's one prominent platform for streaming massive data to the web. So the like new thing in here, or one of the biggest like innovations that's currently happening, is that you can stream these massive data to web browsers, and you can be viewed with mobile. They are not like heavy loading too much on the device, because it just continues to increase and increase and increase the resolution as you are going forward. You are seeing this, right? Yes, good, okay. So I'm just gonna go a bit closer and closer, and this is a scan that has been done on the canopy on the trees after the California wildfire, and you can really see high level of detail, which keeps increasing as I move closer, but eventually you can really see individual trees. So you're seeing this black and white because the way LiDAR works, it doesn't collect color, but you can, in post-processing, you can color this, but even more importantly, you can, for example, visualize the height and the kind of thickness of the trees using some kind of color map. And then you could, for example, take a scan from before the wildfire and take the scan after the wildfire, and then you have already a quantified data of exactly the effect of the wildfire in terms of like the density of the forest, the height of the trees, how many leaves, and so on. Because as you can see, this is so detailed, and over such huge landscape, you can do this scan over like an entire state. So that's just one example. Yeah, so I was talking about this, but some use cases for LiDAR that I have seen. For example, you can quantify the climate change effects in the atmosphere. You can do also LiDAR on gases. You can find like the concentration of gases in the atmosphere. You can quantify the damage after natural disasters. You can detect areas that are in risk. For example, if, let's say you are investigating landslides, you can detect these areas where there's a, because of the way the terrain is formed, that there's a high risk of landslide. You can do simulations of floods, for example, as a result of climate change and landslides also. And now this equipment is becoming ubiquitous because iPhone 12 is actually coming with a LiDAR scanner. Of course, it's not like this airplane style massive scale, but you can start even doing LiDAR scans of your own environment in iPhone 12, also iPad Pro of 2020. And as I mentioned, the data set is increasingly expanding. For example, I have looked in Finland's public data set of the Hanhikivi nuclear power plant. And for example, I could see easily where they have been digging and like what's the state of the ground there. Everything this is accessible now to the consumer via web. So that was one case, which is the LiDAR. Next, I want to talk about the photogrammetry. Photogrammetry is a technology with just a standard camera taking images. You can create massive 3D models of any environment. And this one is already being used in the New York Times in stories that they're having. And I'm going to show you one example. This is a story that was published this year about Queens, the neighborhood in Queens in New York Times. And for this story, they did a photogrammetry scan of the entire street. So once we start scrolling down here, reading the story, then we end up reaching to this place and it just expands. And here we are already 3D traveling in this street with the information from the Times overlaying the items. So, and this is again done by just a standard camera, and the photogrammetry technology uses these hundreds or thousands of 2D images to construct a 3D model of the entire street. So this has already been done at the New York Times and I guess in other places, but that's another kind of teleporting technology. And then the last thing I want to talk about, I was talking about mediums. So one question I'm having is, can we cross material boundaries while maintaining the relation between our bodies and the environment? So like I was saying earlier, how can we combine this local and the global? There is this dystopian short story from 1909 by E.M. Forster, which describes a situation quite creepily similar to what it is now, but is in this kind of situation where people can't go to the ground, they can't breathe the air there without the respirator, and they are sitting underground, and there is something called the machine, and they are always stuck to their machine, looking lectures and talking to other people. And in that story, the one character tries to get out and rediscover the relation between body and environment, like how is distance in relation to the body, and so on. So this is kind of the danger if we are in this virtual medium all the time, that we start losing the relation to the actual earth that we stand on. And I will also mention briefly a problem called the dual ecologies. If you, for example, see here this kind of robot that's moving, but it has a display with a person sitting inside the display. So we are having a kind of discrepancy, a contradiction between this flat virtual space from one place and then another object that's situated here. And the question is, how can we circumvent that? I will go into my own PhD research about that. But first thing I want to bring up is, so I've talked about virtual reality, but there's also immersive augmented reality, which probably many of you know, but it's becoming also more ubiquitous and available through the web. And I can tell that from my personal experience, when you are using this technology, it feels a bit more situated, more connected to the ground, like you are not having this immense mind-body split, even though you are viewing this virtual information. So you are holding your phone and you are just like looking at another, like at a teleported place, like through your phone. So this is still not this, like it's partly virtual, but in my opinion, this feels more connected to this terrestrial than a virtual reality when you are using immersive augmented reality. And finally, I want to bring up my own research. This is actually from my master's, but I have been working with telepresence robots, meaning a physical robot that is present in one location and is remote controlled by another person, and then you are having this um, physical interaction with it. So here is another kind of form of teleportation. You can teleport here a human, but also you don't have to teleport a human. You can create a robot avatar for whatever you want. But in here, if you are not showing any display and not having these dual ecologies, then you are having a completely situated medium. This robot is in here with you, even though it's connected to somewhere else. And I see this as a technology that allows us again to bridge, this geographical, physical gaps and boundaries that we have, but still maintain a connection to the environment where we stand. And even if it's metaphysically, psychologically, it's still important. And moreover, what I've been working on are soft telepresent robots. So not only they are like robots that are um, remote control, but I also try to make them with soft materials that have this kind of soft and non-linear motion that, in my view, contradicts, this mechanistic view of science. So it you are not thinking about things more like very linearly and mechanically, but it's gives a more organic feel and touch to the whole experience. So I feel that having these soft robots is a bit more kind of connecting to nature or terrestrial. And yeah, I think that's all I had to say. These are references I have been talking to. I can also share it later with anyone interested. And I'm, of course, happy to answer questions if